Hello everyone. So here we are again. For today's discussion, we will talk about the greatest integer function or the greatest integer value of a function. If x is a real number and n is a natural number or a positive integer, such that n is between x minus 1 and x, with the possibility that n is equal to x, we say that n is the greatest integer less than or equal to x. And we write n is equal to the square bracket of x. On the other hand, the left brace and the x enclosed by the left brace and the upper and the right brace is equal to x minus n, which is the fractional part of x. So here, the fractional part of x is between 0 and 1. It may be 0, but it should be less than 1. For example, the greatest integer value of 5.7 or the greatest integer value of 5.003 and the greatest integer value of 5.97, they are distinct numbers, but their greatest integer value is the same, 5. But they have different fractional value or fractional parts. The fractional part of 5.7 is 0.7. The fractional part of 5.003 is 0.003. And the fractional part of 5.97 is equal to 0.97. Also, for negative integers, the greatest integer value of negative 4.74 is equal to negative 5, because on the number line, negative 5 is to the left of negative 4. And the fractional part of negative 4.74, by definition, it's equal to x minus n, where our x in this case is negative 4.74 and our n is negative 5. So we have 5 minus 4.74, which is 0.26. We have here some exercises. Find the greatest integer value of x and the fractional part of x. Number 1, x is equal to 5 times the square root of 7. So here, first we take the square of x, which is 25 times 7, which is equal to 175. Now, since 13 squared, which is 169, is less than 175, but 175 is less than 196, which is the square of 14, then it must be that that x is equal, which is equal to 5 square root of 7, must be equal to 13 plus 5 square root of 7 minus 13. Now, to make sure that 5 square root of 7 minus 13 is less than 1, note that if uh, a square root of b minus c is less than 1 if and only if a square root of b minus c is positive and a times the square root of b minus c plus 1 is negative. Okay. Since 5 square root of 7 minus 14 is equal to 175 minus 196 over 5 square root of 7 plus 14, and this is 21, negative 21 over 14 plus 5 square root of 7. So this is negative. So we are sure that 5 square root of 7 minus 13 is really between 0 and 1. Therefore, the greatest integer value of x is 13, and the fractional part of x is equal to 5 square root of 7 minus 13. Okay. Number 2. We have x is equal to 2 plus square root of 3 times the square root of 13. Now, the square of 3 times the square root of 13 is equal to 9 times 13, which is 111. And again, note that (100), which is 10 squared, is less than 111, but this one is less than 121, which is 11 squared. So therefore x must be equal to 2 plus 3 square root of 13, which we can write as 2 plus 10 plus 3 square root of 13 minus 10, or this is equal to 12 plus 3 square root of 13 minus 10. Again, using the result that we have in the first problem. If you increase 10 by 1, that means we have 3 square root of 13 minus 11 would be negative. Okay, since 3 square root of 13 minus 11 is negative, this is we have the greatest integer value of x is equal to 12, and the fractional part of x is equal to 3 square root of 13 minus 10. And then for number 3, we have x is equal to 5 over 3 square root of 11 minus 8. First, we rationalize the denominator, so we have 5 times 3 square root of 11 plus 8, and then below we have 9 times 11, so that's 99 minus 64. So this is 40 plus 15 square root of 11 over 35. Okay, now here we have to change 40 into a number which is a multiple of 35, so that when we divide, we get an integer. And the smallest, no, we can still, let us reduce this one first. Divided by 5, that's 8. This is 3 square root of 11 over 7. Okay, so now instead of changing 40 into a multiple of 35, we change 8 into a multiple of 7. Now, since 3 square root of 11 plus 8 is greater than 3 square root of 9 plus 8, which is 9 plus 8, which is equal to 17. We have x equals So we change the 8 into 14 plus 3 square root of 11. Since the original was 8, so we have to subtract 6 over 7. So we have 14 divided by 7 is 2 plus 3 square root of 11 minus 6 over 7. And again, 3 times the square root of 11 minus 6 over 7 must be less than 1. Otherwise, the greatest integer value of x would not be 2. And if we again test whether that one, the irrational part is less than 1, we note that a square root of b minus c over d is less than 1 if and only if a square root of b is less than c plus d, and therefore a squared b is less than c plus d squared. And we see that three square root of 11 squared is equal to 99, which is less than 6 plus 7 squared, which is 13 squared, which is equal to 169. So the irrational number 3 times the square root of 11 minus 6 over 7 is really less than 1. Therefore, the greatest integer value of x is equal to 2, and the fractional part of x is equal to 3 square root of 11 minus 6 over 7. And for the last exercise, we have number 4. Number 4, we have x equals 7 over 11 minus 3 square root of 10. Again, rationalize the denominator. So we have 7 times 11 plus 3 square root of 10 over square of 11 is 121, and square of 3 square root of 10 is 90. So we have 77 plus 21 square root of 10 over 31. Okay, so again, we must change 77 into a multiple of 31. Now, and how do we do that? Well, let's look at 77 plus 21 square root of 10. This is greater than 77 plus 21 square root of 9, which is 77 plus 21 times 3, that's 63. So 77 plus 63, that's 140. That's 140. So we have x is equal to and a multiple of 31 which is less than 140 is 124. So we use 124 here. We have 124 plus 21 square root of 10. And since we have used 124 instead of 77, so we subtract 124 minus 77, that is 47. All over 31. And 124 divided by 31 is 4. So we have 21 square root of 10 minus 47 over 31. And again, to make sure that the irrational part is less than 1, we look at 21 times the square root of 10, square that one. So this gives us 4410, and 47 plus 31 squared, this is 78 squared, which is 6084. Okay, so therefore 21 times the square root of 10 minus 47 over 31 is less than 1 but greater than 0. So we have since 4410 is less than 6084, we are sure that the expression 21 square root of 10 minus 47 over 31 is less than 1. That is the greatest integer value of x is 4, and the fractional part of x is equal to 21 times the square root of 10 minus 47 over 31. Okay, so that's it for today.